Good morning, everyone, and welcome to our first parallel session. Our topic here is multiple pollutant sources and other environmental exposures. And so we have a great set of panelists here. And to not take time away from them and leave time for discussion, I'm just going to start by introducing Chris Uejio, who is one of our HAQAST PIs. And Chris, let me give you the microphone.
Hi, I'm Chris. I'm one of the HAQAST members. Always, it's a pleasure just to have you. Welcome to those of you who are, this is one of your first times here. So I'm in thinking about what to talk about, we have a bit of leeway, but I had to think about it a bit. But when I thought of the connection between Utah and Florida, I immediately thought of presenting our work on Orlando. So if you've seen the Book of Mormon, it's the sort of one of the quintessential destinations. So our urban heat and health project there, really a lot of this is I'm going to credit Brittany Sellers, who's their city sustainability director. And then just some brief background on heat. Heat is the #1 cause, weather-related cause of death in the United States, more than hurricanes or cyclones or tornadoes, and it can be largely preventable. Sure, maybe back a slide. Sure, okay, great. Transition smooth. So what do you folks think of when you think of Orlando? Disney. Great, Orlando and Disney? Awesome. Okay, but no, don't worry. So something potentially maybe not unique about Orlando, but it is really when you're thinking about emergency planning and disasters and resilience and things like that, for each resident in Orlando, and Orlando's not a small city, right? We have 245 tourists that are there on average at any given time. So really, when you're talking about things, whether it's heat, yes, so we're both going to be interested in the residents that work there, the workers working in tourism, as well as the tourists who are largely not going to be acclimatized or familiar with some of the hazards in that area. So the city's sustainability goals, they are trying to meet some of the sustainable development goals as proposed by the United Nations. Some of those are fairly ambitious, 100% renewables, maybe not unlike other large cities in the United States, but a 90% reduction in greenhouse gas emissions compared to 2040 levels, slightly more ambitious. Reduce water consumption and zero waste. And this sort of project serendipitously came about as Orlando was looking for more support in these areas. We don't have all this expertise in HAQAST, but we certainly have some on heat and air pollution to a lesser extent. Sorry, air pollution obviously to a greater extent, and then to a lesser extent, drop some of these other ones. And so what are some of the challenges? Obviously, it's not unlike other places. Certainly resources, some of the trade-offs, some of the priorities for the city and their partners would be green, clean jobs, some of the health co-benefits and trade-offs and disaster planning. Okay, I'm going to transition to the NASA part. So this will be in my next X talks just for a NASA audience. But this was a survey of planners done by Heath and Sarah Mira, both Arizona State and then University of Arizona researchers. But essentially, like what are the information sources that city planners actually use? And what do they perceive not to be available? Which is sort of a critical HAQAST goal for us. So obviously vegetation tree maps, the orange bars saying there's more widely used and available or perceived to be available. If you hit the next. But really where we're trying to fit this gap is these land surface temperature maps, right? Only about, sorry, if you go back a second. Only about 20% of these city planners respond to the survey, and these are going to be include some relatively large municipalities actually use them. And for many of you in the room, you probably would say those are probably available, right? To some extent. But they're maybe not in available formats and maybe aggregated enough for them to understand how to use them. And then sort of correspondingly, heat vulnerability maps also being not particularly available. These aren't, I'd say our innovations in heat vulnerability aren't anything earth-shattering, but they're just still needed. So that's really where this is. We view this HAQAST and other NASA-related programs as filling this gap. Next slide, please. So human thermal comfort. Probably there's been a lot in the literature, right? This past summer was a doozy. Everyone know heat is now on everyone's mind, at least temporarily. We know that it's a complex set of energy balances and environmental influences that relate to who actually gets sick and dies prematurely of heat-related illness. And then connecting that to more NASA Earth observations, right? We know we can get land surface temperature or surface skin temperature, the temperature of the very surface layer. But in places where you're in a downtown setting or urban corridor, you're also then sort of mixing that, if you will, or we're also getting information that is not as so helpful, such as the temperature of the tops of buildings. So land surface temperature in itself can be helpful, right? Then this past summer, there were 100 or so cases of people actually just getting burned in Phoenix from the concrete, right? So that's a directly relevant metric. But for a lot of the epidemiological studies, they're really focused more on air temperature. So we're trying to get at that through a variety of approaches. Next slide, please. Broadly, obviously NASA Earth observations, sort of the newer ones, if you will, be the eco-stress which drives aboard the International Space Station, and trying to resolve at least a day-night, not quite a diel or diurnal pattern. I don't think we quite have that sort of data availability yet, but ideally. And then really sort of what's really making this more accurate is splicing in a lot of weather data from private weather stations who are making it open. And that's really allowing us to get more accurate sort of neighborhood level, not just estimates of heat exposure at the air pollution community says nose level, I'd say thyroid level for your heat sensing. Next slide, please. This is just a map for Orlando. We haven't done this full analysis yet. It's a work in progress, but this is predominantly black zip code that has the highest rates of heat-related illness. So even just providing this is, which I know not a huge step, but is just connecting these actors and sectors has been important. And then we can provide some evidence where to target their interventions, whether it's tree planting campaigns or something more proactive. And then, sorry, I actually thought I was going to be a bit short, so I added a bit more. So to segue a bit onto air conditioning. So when I bring up air conditioning, depending on the audience, half of the audience, sometimes I might immediately lose about half the audience because people are concerned about the increase in air conditioning saturation, particularly globally, and what that would do for greenhouse gas emissions and therefore exacerbating inequalities. But from a health perspective, whenever I'm mandating one solution for one group of people, air conditioning or central air conditioning, and a wall or window units or no air conditioning or fans for another, right, I'm creating a health inequity. So for that being said, you're welcome to have your opinions, but unfortunately for heat-related illness, having access to air conditioning and you being able to use it is our #1 most effective intervention to preventing it. And there's not a lot of ways to get around that, right? And that's not saying everyone should be able to chill their home to 68 degrees Fahrenheit in the summer, right? But providing equitable access at a reasonable temperature to keep you safe. Next slide. So broadly, everywhere, long story short, air conditioning saturation is increasing. We know that from broad surveys, but we do not know, unfortunately, what neighborhoods where this is happening. And if you guess just like air pollution or other environmental exposures, the areas where it's not increasing are probably going to be the same places where you have increasing or stagnant environmental exposure levels. Next slide, please. So we've partnered with a real estate company, as stated. We've also used Zillow data, but we're trying to really get at the first updated census tract level air conditioning prevalence estimate since 1980, since that's when the US Census stopped collecting it. Broadly, I probably don't have time to go through all these, but this is the outcome variable is percentage of households without air conditioning. So this tracks largely what you would expect for neighborhoods, people of color, the housing stock. and that neighborhood influences whether you were able to upgrade that to get central air conditioning. And I think next slide might be final. Oh, just mapping it out. Right. Long story short, even though it's Florida, and I've worked in other cities where air conditioning saturation is 95, 99%, Atlanta, Houston, et cetera. But even in some parts of Florida, there's certain counties that are only at 80% still, which means saying that maybe it's not as high as maybe we thought. Okay. Thanks for your time.
Great. And then we have Sakka, hopefully I'm pronouncing your name correctly, from the American Cancer Society speaking next.
Hi, everyone. Can you hear me? Yeah, okay. And when I say cancer care continuum, I mean early detection, diagnosis, treatment, survivorship, and palliative and end of care, life care. Sorry about that. And the team is also interested in environmental exposures and healthcare disparities and structural racism. And this paper is an excellent example of research that was conducted highlighting how climate-related disasters can also impact the cancer care continuum. So now I'm just going to talk about the different types of pollution and how they can cause different types of cancer. We're all aware that air pollution can be linked to lung cancer. And in the United States, it is estimated that there will be 238,000 new cases of lung cancer this year alone, and there will be about 127,000 deaths. There's also bladder cancer, which can result from occupational and residential exposures to polycyclic aromatic hydrocarbons and also volatile organic compounds. There's liver cancer, which is associated with the presence of arsenic in water contamination. And there's skin cancer, which is associated with UV radiation exposure, which can be linked with the ozone layer depletion. And then we also have breast cancer, which is linked to exposure to herbicides and pesticides from soil pollution. And lastly, we have leukemia, which is blood cancer, and that can result from exposure to benzene vehicle exhaust. Pollution can also cause other illnesses such as asthma, respiratory infections, and heavy metal poisoning. And these conditions also matter because pollution-related illnesses can be also labeled as comorbidities and are associated with worse cancer outcomes. So in a previous collaboration with the NASA HAQAST group, we leveraged NASA satellite data to evaluate the association between wildfire exposure and lung cancer survival. And the finding was that wildfire exposure was in fact associated with worse overall cancer survival. And following this paper, many news articles came out, and it was also, it got a lot of attention from radio stations and magazines as well. So because our research aims to inform policymakers, we're interested in studying and analyzing sources of pollution that policies can have an impact on. So for example, the cancer prevention studies that we conducted informed the air quality standards for the Clean Air Act. And some of the pollution sources that we're interested in include wildfires, which emit PM 2.5 and PM 10 particles, and also carbon monoxide, nitrogen oxide, and VOCs. Other common point source solutions, multiple source pollutants include hazardous pollutant infrastructure such as factories, power plants, waste incineration plants, and industrial facilities. And these increase exposures to carcinogens such as nickel, cadmium, and benzene. And then we also have transportation routes and highways, which also expose workers and residents to carcinogens such as diesel exhaust particles, benzene, and formaldehyde. Other sources of pollution we would be interested in are landfills and waste sites, which pollute the air, water, and the soil. Landfills emit fumes and chemicals into the air, such as methane, VOCs, hydrogen sulfide, and ammonia. The use of herbicides and pesticides in concentrated agriculture can also contribute to air pollution, and they can volatilize and evaporate into the air after application. And some of these also undergo chemical transformations in the atmosphere, and they can lead to the formation of secondary pollutants. And then lastly, we have animal feeding areas, which are other multiple big pollutant sources. They can lead to nutrient runoff and into the soil, and they can also contaminate water bodies. So livestock can release significant amounts of methane and ammonia into the air, and also odors. And ammonia can react with other pollutants to form PM 2.5 particles, which can also lead to adverse health effects when they're inhaled. So as you probably heard from the NASA Tiger team on environmental justice, due to discriminatory policies and practices, hazardous infrastructure is frequently sited near communities that are targeted for marginalization, and they've been disenfranchised from resources that are necessary to oppose such developments. So it is important to document these environmental justice disparities so we can help inform decision making, and so we can advocate and raise awareness for their rights to reside in clean, safe environments, just like everyone else. Thank you, everyone.
That was great. Thank you so much, Rand. And I believe next up is Randall Martin from Washington University of St. Louis and one of our HAQAST PIs. Sorry.
Wasn't sure.
Yeah. Okay.
Thanks. Well, thanks for the chance to provide this update on our satellite-derived PM 2.5 estimates. And I wanted to begin with a good news story that identifies a global reversal in air pollution or PM 2.5 exposure worldwide. So the top left panel is showing you the trend in global satellite-derived PM 2.5 in the first decade of the millennia. And you should see that most countries exhibited an increasing trend as indicated by those warm colors. The bottom left panel is showing you the more recent decade, and the transition from those warm colors to cool colors indicates that overall worldwide reversal that is occurring. The top right panel is showing the global population weighted PM 2.5 exposure. The colors are indicating specific countries or regions. Those are described at the bottom right. And what you should see is that that turning point occurred somewhere around 2011 to 2013. It is being driven by China, which is the color in red in the bottom of the top right panel. That's a large driver, but you're seeing contributions from a variety of countries and regions around the world, all contributing to that reversal. The remainder of this talk, I'd like to focus on our efforts to further develop and improve our satellite-based estimates of PM 2.5. And this is motivated by the uneven distribution of PM 2.5 monitoring worldwide, with large gaps in PM 2.5. I should do a shout out to OpenAQ. A large part of this data is from OpenAQ, you'll be hearing about momentarily, but also from additional sources. In addition to this uneven distribution, another complication is that the data are spatially autocorrelated. And by that, I mean that a value measured at a certain location tends to be similar to a value measured nearby. And that'll be a complication in the analysis that I'll get to in the second half. Our overall approach for satellite-derived PM 2.5 begins with aerosol optical depth from a variety of NASA satellite instruments and algorithms, all inversely weighted by their relative errors with respect to AeroNet that accurately measures aerosol optical depth from the ground. This enables production of a composite estimate of aerosol optical depth. We then coincidentally sample that aerosol optical depth data set with a chemical transport model, GeoSChem, to calculate that time and space varying relationship of aerosol optical depth with PM 2.5 to produce a geophysically based estimate of PM 2.5. Then we follow that up with a statistical fusion with ground-based monitoring to produce an overall hybrid PM2.5 estimate. And the development that I'll examine today is the application of deep learning to further develop those estimates. And there are two different approaches that I'll examine. The first will directly take the aerosol optical depth and use the ground-based monitoring data as truth to train the deep learning model and directly produce PM2.5 estimates. The second will build upon that framework that I introduced earlier, first proceeding to a geophysically based estimate of PM2.5 that uses geochem information, and then applying deep learning only for that subsequent statistical fusion to produce the estimates. The specific flavor of deep learning that we'll use here is a convolutional neural network. And the left panel is showing you the approach that uses our geophysical a priori information. It uses the geophysical PM2.5 data as well as geochem output information. The rightmost panel excludes everything from the geochem output or the geophysical PM2.5. It still includes everything that would be used as an input for a chemical transport model. What you're seeing here is the evaluation of these two different approaches in the form of an R-squared through a traditional cross-validation approach in which a fraction of the data are withheld for testing and the remainder used for training. In a traditional cross-validation, oftentimes 10% of the data are withheld for testing. And that's what you'll see in the leftmost column of both of these panels. And in both of those cases, in that traditional approach, both approaches perform well. But then we'll increasingly reduce the amount of data available for training for the purpose of identifying performance in regions with sparse monitoring. And when we withhold increasingly severe amounts of data, so withholding 90% of the data for training, for testing, or 95% of the data for testing, what you'll see is that using a geophysically based a priori leads to a more robust estimate with respect to reducing availability of monitoring. Now, I wanted to return to that issue of autocorrelation, and I'll use, even though our focus is spatial autocorrelation, I'll use temporal autocorrelation as an example because it's compellingly visual. What I'm showing you here are two different PM2.5 measurements located about 1 kilometer apart in St. Louis. And what one can obviously see is that they very closely follow one another. And excluding one of those sites for testing while using the other one for training requires no real statistical skill, but rather it's just can be inferred. Quantify that in a space by examining the semi-variogram PM2.5 spatial autocorrelation. So the leftmost panel of distance, that is low when the distance is of kilometers because neighboring sites exhibit similar values. That variance increases as sites are further away from each other because they become less autocorrelated. Our approach to address this is to identify a buffer region. We'll exclude all training data around a test site and vary the spatial scale of that buffer in order to reduce the effects of autocorrelation in our analysis. There are a lot of lines here. This is showing you the effects of that buffer leave one out cross-validation as a function of buffer radius. The red line is showing you the performance of the geophysical a priori. It's independent of the monitors that are used for training. It's purely geophysical. The other lines are showing you our deep learning framework. And what one should see is that when the buffer radius is 0, so this is a traditional cross-validation approach, that all these different algorithms perform well. But as that buffer radius increases, the approach that excludes the a priori geophysical information degrades more rapidly. That's the yellow line, as opposed to an approach that uses that geophysical a priori. That's the green line, sustains a higher level of skill, even when distance becomes larger with respect to the monitors. That's because it's relying more strongly upon the satellite data rather than upon the ground-based monitor data. So with that, I'd like to leave you then with this identification of the value of using a geophysical a priori that strongly relies upon satellite data for the inference of PM 2.5 in regions with sparse monitoring, and remind you about that good news story that we have in satellite-derived trends in PM 2.5. Thanks for your attention.
Great, thank you, Randall. And our last speaker before we open up for discussion with our panel is Chris Hagerbaumer from OpenAQ. So that was a nice connection with the.
I'm amused that we have a Chris and a Christine, although I go by Chris, and then we have a Ran and a Randall on this panel. So that's cool. I don't know if Randall ever goes by Rand. So as she's bringing this up, I'll just ask first, who in the room has heard of OpenAQ? Cool. Who in the room has used OpenAQ? Cool. Okay, well, what I'm going to do today is basically describe a little bit about who we are and where we're going and how we interact with satellite data. We are ground-based air quality data. Okay, what do I press to move forward? Oh. All right. We are a small but mighty team, just two folks focused on tech, and then a person focused on getting the word out in the world that we're available and doing trainings, and then me sort of managing the organization and fundraising and fun stuff like that. So what is the OpenAQ platform? We are the world's largest open source platform for ground-based air quality data. And some of these figures are a little bit old. I think we have more than 53 billion data points, and we're in 153 countries around the world. We're always looking to expand. We focus on criteria pollutants. We've got a few other pollutants sort of randomly on our platform. And we're pulling data not only from reference monitors, but also air sensors or low-cost sensors that are proliferating around the world, thankfully. And I would differentiate us from, we're nonprofit. There is another nonprofit platform, AQICN, WAQI. They're putting out AQIs, air quality indexes. We're providing raw data to the world, which is useful for science, right? And I would differentiate us from the many private platforms out there in that, you know, there's no paywall, there's no black box. We're giving you that data as raw as we can. So, oh my gosh. Okay, I just went on a trip to Britain and Iceland, and I took adapters with me for electricity, right? Well, it seems like everybody around the world produces air quality data in a different way. So we're talking in the world for electricity, what do you need? A couple dozen adapters, maybe less, I don't know, 10 to 20. For air quality, it's like you need hundreds of different adapters, and we have to build those adapters in order to bring the data onto the platform. Sometimes a country might be producing data, they're putting it on a PDF, and they're putting it somewhere deep in a website. And so how do you even get that data? You scrape it. So we're trying to solve a problem by bringing on data, by building these adapters and then standardizing that data so it's much easier for folks to use. Data often exists very temporarily, so we're trying to grab that before it's gone. And just what I said, this data is not interoperable, and it's often not accessible to the public. So we're, again, trying to bring all that data together and standardize it and make it easy for you to use. Well, I shouldn't just say try, I will say we are. So this is just, yeah, this is what we do. Aggregate the disparate data, harmonize it, and then it's utilized by lots of different types of folks. Everyone from the researchers and analysts out there at a variety of institutions, governments, public health entities like our earlier American Cancer Society can use this data. And thank you again for everybody on the panel for really interesting talks. NGOs and community-based organizations, journalists and storytellers to tell the story of why air quality is so bad around the world, app developers and other sort of technical companies using the data. And sometimes it's not even an air quality related person using the data, but just people who are enthusiastic about big data sets and they use it for just to sort of learn. This is just an example of a paper that took both satellite data and data from OpenAQ to look at the immediate impact of COVID lockdowns on air quality. There was a lot of research around COVID and air quality over the last few years. I want to talk a little bit more about these because these use NASA data. AQAI is the two wonderful young scientists have created this company and gotten some backing from UNICEF. They both worked for UNICEF. And they're leveraging artificial intelligence and machine learning, fusing real-time satellite imagery and ground-based sensing, that OpenAQ being the ground-based, and they're replacing stale air quality data being used in health impact assessments. It's a predictive model that shows child population density against regions with pollutant concentrations above WHO recommended limits. And then predicting what we breathe was funded by NASA's Earth Science Technology Office, a partnership between the city of Los Angeles, California State University in Los Angeles, and OpenAQ. And this developed a highly accurate model for LA County that provides hourly air quality predictions for 6 pollutants at a spatial resolution of 1 kilometer squared. The average accuracy over a 24-hour period is about 94%. And it's even 10 days into the future, the model is still doing quite well at predicting air quality levels. And this was developed using both artificial intelligence and machine learning, applied to satellite observations, ground level air quality data, meteorological data, and wildfire smoke data. It's being expanded. You can now look at all of California. There's a predictive model, and this is available to cities worldwide to be able to kind of replicate this model. New funding from NASA ROSES is going to also add integrate more socioeconomic data into the model. So we're pretty excited to be involved with this. This is a fun is not the right word. Smoking cigarettes is not fun. Well, maybe to some people, but but basically it's saying, you're breathing this air every day in the city. It could be the equivalent of in some places, smoking a pack of cigarettes a day, if not more. So this is an app that was built for free by a couple of folks in France. Pretty cool use of both OpenAQ and WAQI. Obviously, what we really want to see is change in the world. And so we're very excited about ways that air quality data is used to inform policy. So Sarat Gutikunda with urban emissions in India has used data from the OpenAQ platform to create visualizations. Those in turn have informed long-term air quality management plans and alerts to the public about what the air is like. So moving forward, okay, our major thing is to make air quality data universally accessible. And we're working harder to make it easier to use. And what I mean by that is, I think a lot of folks in this room, you might be data wranglers. You know how to go and use the API. You know how to work with big data sets. But you're probably 0.0000001% of the entire population, right? How do we get other people to use this data? So we're building more tools, and our focus is really also you saw in Randall's presentation how much of the world is without air quality data, right? So we want to see as more data in low and middle income countries and in environmental justice communities. We're out and about evangelizing the fact that the platform is there for folks to use. And we know people all over the world doing this work. So we want to make connections between people to facilitate more collaboration. We produce a report on the global landscape of air quality data, what countries are monitoring, and of those that are monitoring, who is sharing data, and it kind of like at what level, right? So in reality, only 25% of the countries that have monitoring are sharing that data in a truly fully useful way, that you can access it through an API, that it's the raw data. And we have a community ambassador program, sort of basically a training program, mostly related to how do you monitor and use air quality data. These are our wonderful community ambassadors this year. I mentioned tools. We released the OpenAQ Explorer in January, and this is the way for even me. I'm not a data person, but I can go onto the OpenAQ Data Explorer, and I can understand how to use it. I can understand how to get the data. And these are examples of our training. So example, you can figure out who's the producer of or provider of that data, all sorts of different things really simply, and visualize the data in different ways. Another tool we recently released is a CLI client, for those who are familiar with that. And lastly, the slide here is just how you connect with OpenAQ. I'm going to say something quickly about funding, which is that I said we're free. Well, we're not really free. I mean, as in it takes money to pay staff and to do all the things we do. So those of you who are scientists and researchers, when you are writing grants, you might consider, hey, a small line item for OpenAQ, because our ability to sustain ourselves really relates to our community understanding how valuable we are in this landscape. Thanks.
Great. So I'd like to invite our panelists to come up to the front of the room for our open discussion of open data sets. And I guess I would also, knowing that a third of our members in the room, this is their first meeting, it would be great. I'd like to encourage all of you who are new to think about participating in the discussion and asking questions. I don't know, I can't tell who's new necessarily, but I just want to put that invitation out there. And so I guess, are there questions to start? I think we have people online that we're trying to use the microphones for, so I will run around. Maybe just introduce yourself.
Thanks for all the presentation. My name is Byung Kim at Georgia APD. I have a question to Randall and Christine. Christine mentioned that there is a heterogeneity in the formats of data, but I think also there are a lot of sort of irregularity and a different degree of the quality of the data across all the world. What's kind of in general your strategy to harmonize or reduce that kind of variability in terms of the quality of the data when it comes down to the quality of the data is very different between the countries?
I guess since that was, is this on? Yes. Yep. Okay. Our approach is to use data that have some level of assurance. So what we'll use are government-run data or a research quality network. At this point, we are not using low-cost monitoring for the data, although we're inspecting that and quite interested in those data as they become more available.
Yeah, this is a question we get asked a lot, and we agree that for scientific purposes, for regulatory purposes, that quality assurance and quality control is needed. We put out the data in the format that it's provided to us, and we do that because we know that scientists have they do quality control in different ways, and we can't really be the arbitrator. We kind of have to be neutral in the space. And we also find it actually helps when you have that raw data, you can actually use that to figure out, is something working well or not working well? And so that's why we have decided we do not do quality control, but we do provide the metadata that helps you understand where it's coming from. And ultimately, we would like to provide, we've been asked a lot, could we provide some of the algorithms and this and that? And ultimately, we'd like to be able to do more of that so that people can apply things kind of off the shelf.
Okay, lots of hands. This is great. I'm going to go here because I'm here, and then I'll come over that.
Thank you all so much. I'm Tark Kandakji. I'm from Yale University. I have a question for Randall and Rand as well. The first question for Randall, probably going to sound a little bit naive, but have you used mixed random effects mixed model for to get rid of the autocorrelation between the different stations? And how the method you used can be sufficient in terms of statistical perspective. And my question to Rand, you showed some pollutants you think might contribute to cancer, but do you think all these pollutants can be captured by remote sensing data? Because some of those needs really high resolution data. So do you guys thought about that? Have you worked in using maybe commercial satellites like PlanetScope that can reach to 3 meters, which can help a little bit? And that's it. Thank you.
Yeah, thanks. That's a great question. For this study, we haven't applied a random effects model to go after the autocorrelation. Rather, we're just examining different frameworks for deep learning applications, considering the variability in applications that exist within the community and exploring what the role of a geophysical a priori can be, and trying to reduce the role of adjacent monitors in informing. But that's another approach that one could pursue.
Thank you for your questions. So we have collaborated previously with NASA, as I mentioned in the presentation. I'm not sure exactly which satellite data is being used for the wildfires. That's kind of their end of the project, but what they do is provide us with the data, and our job is to analyze it. And I know that John Haynes also presented the new satellite Maya that's going to be used. So we're looking forward to also utilizing that data.
Okay, I'm gonna start with you.
Sorry, Gage. Hi, May McMurdo from the Cleveland Clinic. Chris, I had a question for you, actually. I mean, first, thank you for doing this heat work. It's really important. I think really going to become, unfortunately, more important. I was wondering, when you're looking at air conditioning use, how you think about energy insecurity and kind of how that plays in. Because it's one thing to have an air conditioner, it's another thing to actually be able to use it and afford to use it.
Yeah, awesome. Great question. So yeah, I think really energy security is really where it's at the end of the day. So I think you could use satellites to get at energy efficiency of the buildings if you also knew who had access to air conditioning and how much they're using it. But we don't know those two pieces. But yeah, broadly, the poorest of the poor households spend about 16% of their income each month on energy usage. So that's the same as food or transportation. So yeah, there's things like the low-income heating energy and assistance program that we're very interested in working with as well with Orlando and Miami. But great, excellent point. Thanks.
From George Washington University. My questions for Christine and Randall. Both documented parts of the world lacking to monitor it. I'm wondering how your work has potentially informed placement of new monitors, and if it hasn't, where you might consider directing funding and efforts geographically speaking.
Wonderful question, because there is work being done on this now. So our founder, her name was Krista Hazenkopf. And it's so funny because my name is Chris Hagerbaumer. They're so similar. Back to the names. In any event, Krista works at University of Chicago's EPIC lab. and she is currently looking at where could funds be directed in the world to help countries actually begin to monitor for PM 2.5. And she's developed a sort of a set of criteria to direct those funds. And part of that actually includes using that report that I shared to determine where are the gaps. So I'll try to remember to, if you bring me your card or whatever, I can send you a link to a recent presentation that she did. But that's I mean, by identifying those gaps, then we know where to send funding. I could go on and on, but I'll pass to Randall.
Thanks. Great question. I think it's hard for me to know where monitors have been instituted as a result of our work, but what I hope that the availability of satellite-derived estimates of PM 2.5 inspires locations to either share their data or to make measurements themselves. So I have heard people from certain countries say that, well, we think our data are different, our PM 2.5 concentrations are different than what you're showing. And our primary response is we'd love to have access to your ground-based measurements that can identify those differences so we can learn from that. And that may facilitate either further measurements or further availability of data. So I hope cycle in that case.
Why don't we go online?
Sure, we have a question from the online audience from David Paget. And he says, would you mind please elaborating on NASA grant opportunities involving NASA air quality data collaboration with socioeconomic data?
Yeah, so this project out of the city of LA is with the NASA Roses is basically going to bring together communities in Los Angeles to ask what additional information they need to bring some of the EJ organizations in Los Angeles together to look at what more do they need to understand about air quality, what other socioeconomic indicators would be useful to them, basically to mesh more of the data together and to support these groups in using it. But it's kind of in a that sort of stage hasn't quite happened yet, so I can't really describe much more, but I think that one can find out a lot of the information at the NASA Roses page. Yeah.
Good morning, everyone. I'm Annie Eiffel. I'm with Healthier Glades, local organization within Palm Beach County. This is for Christine. In regards to the OpenAQ, I noticed I actually went onto your site while I was sitting here, and I noticed that you have a monitor in Belglade, Florida. But given that it is a large agricultural area, is there reasons why there are not more monitors along the other communities around the lake?
Yeah, so just to make it clear, OpenAQ has no monitors anywhere. We are aggregating from others who provide this information. So, so we can only gather data from places that do this monitoring. And this would be an excellent point for you to make to your local government. Or there are going to be more opportunities from through the EPA for community-based groups to get funding to do their own air monitoring. A bunch of grants were awarded last year, and I think there's going to be many more opportunities for those. In that case, you would put in, I'm sorry, I can't really see you here. You would put in, you'd get some funding to do some air sensing yourself. But I think this is a point you want to make to your government, that there need to be, there are so many sources of air pollution, including agriculture, and that would be an excellent point to make.
Yeah, with it being a political hot potato in my community, I was just wondering why it was just one. So I know they've done some air monitoring, and of course that's a rural area. Internet is also an issue in that with that as well.
Hi, I'm Amir from Google Research. So my question is, I guess OpenAQ is a kind of a data repository for raw data, as you just mentioned. But your users, one of them was journalists. So as you know, as maybe most part of the community knows, lots of these data goes through a more of a complex calibration methodologies. And maybe the last product of the PM 2.5 might be 20%, 30%, sometimes 50% different than what you would see or more of a like a validated reported value of the local government data, especially in the areas that are more capable of these methodologies. Now, you put journalists and your users now. If a journalist use your data set, then you're having multiple scenarios being communicated with the people. And I'm talking based on the experience that could actually cause a lot of misinformation. So has there been any efforts from OpenAQ to, because there's been a lot of global or local calibration or filtration methodology, so at least could give some layers of validity, to the data set?
So firstly, again, the government data is going to be quality. Randall uses government data because it's got the best quality control. Some of the air sensor companies, almost all of the air sensor companies, have some sort of level, some sort of checks. But what I would say, some of them less so, and they are very interested in they ask the scientific community, tell us what we should do. And again, we're not actually aggregating from that many different air sensor companies, but what I would say is that, yes, it could be off. It could be off in either direction. But in general, the trends are similar, right? So if you're looking at trends, the trends are going to be similar with a low-cost sensor as compared to a BAM or whatever. So yes, one could miscommunicate. And I'm going to give you one example here of our strategic partnerships director was in Ghana, and the Ghana Environmental Protection Agency was very upset because some newspaper had written an article on Ghana has the worst air pollution today, and they were only getting information from a low-cost sensor. And so Colleen said, gosh, that's a great example of if you put your data out openly, your better sensor, then that journalist could have looked at your data, but they didn't actually have access to the government data. So in a sense, we're hoping that this type of thing actually gets more governments to open up their data, which is the higher quality data.
Thanks.
Hi, I'm Meryl. I'm with the NASA Severe Program, and I have a question for Chris. I was wondering if you could go into a little more detail on the methods from converting from land surface temperature to air temperature and kind of the feasibility of doing that and where you have very limited ground data.
Yeah, thanks for the question. My collaborator is going to be disappointed at me, but broadly, it's not quite a vertical profile, but essentially from MODIS, I wouldn't quite go that far, but essentially trying to estimate from MODIS to sort of constrain their solutions to go to, and then I think probably the biggest, there's sort of a satellite fusion aspect. Primarily, I think for EcoStress is what we're using at the moment, just to provide sort of one-off pictures, which I think are going to be comparable to what NOAA's doing with their community-based heat mapping workshops, where they take just 1 to 4 measurements on one day and call it a day. So that's not bad, but essentially then from there, we've statistically done it with generalized additive models. We're looking at something more advanced and machine learning wise past sort of random forest to try to get at more of converting from land surface temperature to air temperature. But really it is the scraping of the private weather stations that, in addition to the NASA data, that is going to provide, we anticipate it's going to provide the greater increase in accuracy. So make sure if you're around, I apologize, but I'll certainly be happy to connect you.
All right, I'm going to move back to that side of the room, but I think I'm going to take the moderator's prerogative to ask a question to the panelists. And what I've been thinking about with respect to the different kinds of data sets that you all are using and bringing together and the types of applications you're using them for, and thinking about John Haynes's talk this morning with this importance of moving to Earth action and kind of having broader interdisciplinary types of studies that are more directly relevant to usable, basically real world decisions. My question for each of you is, so whether you're thinking about cancer patients and the multiple exposures that they're facing, or heat in Orlando for the tourist versus the residents, and how do we better map or quantify the air quality for specific health applications, right? There's different levels of accessibility that has come up in some of the earlier questions for different data sets, whether it's more on the health side and access to health records needed for epidemiologic studies, or the sort of what do you have for air quality in my particular community, where sometimes you only have one monitor, or maybe you have a lot, but they're of different quality or giving you different information, or maybe just telling you the same thing, as Randall pointed out. So I guess, sorry, this is long-winded, but my question is, what do you see as the biggest barriers? And do you see like ways that we can, as a community, be working to better bring together these different data sets to allow kind of the ability to answer new questions that society is trying to deal with? I don't know who wants to go first.
Okay, so for us, like I said, air pollution is a big one, and I mentioned how marginalized communities also have a lack of funding. My colleague over there emphasized that as well. So I think NASA satellite data can capture data from all over the country and all over the world. So even for marginalized communities, that would be easy to capture. But I guess on-ground sensors that would capture more accurate data, such as the fumes that I was mentioning, I think highlighting those gaps would be very efficient in getting governments to open up their eyes and kind of be more motivated to fund projects like this and implant air quality sensors on the ground, just so we can have more information that we can research in the future.
Yeah, super question. I mean, on one hand, I think for air pollution, there's a sufficient amount of evidence that I don't know if we necessarily need to show more evidence on the sort of like personal monitoring side to compel action. But I think trying to translate those tools for example, in Orlando, there are a couple of community groups and environmental justice groups that have been pushing on this issue, and they're not necessarily having, maybe they have some sympathetic ears in some parts of the city, but not necessarily having the sort of also top-down push to sort of collaborate and to help build them out. I think there can be that sort of breaking that traditional academic silo a bit more to be helpful. Yeah, and I think essentially these mechanisms that NASA has for environmental justice and for IDS, interdisciplinary science programs, that are requiring community-based groups to be partners on the grants are really helping to push that forward too.
A great question, Arlene. A lot of different possible answers. I'll just be succinct and suggest one, which is that when I think about action, I think about what are people going to do to reduce their air pollution. And the way to get at that is to try to understand the sources. And the sources, we get information on that from the chemical composition of PM2.5. And so for that, I would love to have greater accessibility of PM2.5 chemical composition throughout the world. When I showed that map for mass alone, if a map like that exists for chemical composition, I bet it's 100 times less or maybe 1,000 times less. It's probably very sparse. And since I have someone from OpenAQ next to me, I'll suggest that wouldn't it be terrific if there was a platform that had accessible information for PM 2.5 chemical composition?
I come from a public policy background, and in reality, we know air pollution's bad, that it impacts health in so many ways. We know fossil fuels have both these air pollution impacts and are changing our climate. We should just gosh darn reduce them as fast as we can. We don't need more evidence now, but that's heresy to say in this room because you're data scientists. But here's the thing, the political will and the push requires that data, it requires that evidence, and it requires it to be, because air pollution is so, like, it can change within yards, really. So we need the specifics, and more of that should happen. And when community groups do it, it's super neat and engaging for people to be involved in what's happening around them. So I want more monitoring and data, but what I really want is action. So let's do as much as we need for that action.
Great, thanks.
Brad Pierce, University of Wisconsin. I have a comment and then a question. The comment is, so our Google colleague said, you know, OpenAQ is not calibrated. I would say it's openly available. That's a great machine learning sort of application to calibrate it. And I would say partner with OpenAQ and maybe get a level 2 product that is calibrated. That sounds like a good ROSES or HAQAST project to me. And then a question to Chris. So you did work that was focusing on population sector kind of dynamics. Have you looked at all about vulnerability because of the job, in particular agricultural workers, construction workers? Is there any data that you can use to look at how those communities are impacted?
Yeah, great question. Also, Rich is also in the room, CDC, but yeah, broadly, unfortunately, the surveillance systems to capture occupational health injuries and illnesses are lacking in that sort of sense. So yes, I have done like a small study with city workers, and even then, these are city workers where you would think that the city has a vested interest. there's cultural pushback to having any sort of blanket sort of regulation based on heat that would limit productivity. So yeah, it's a huge gap, particularly for construction workers, farmers, the undocumented, that we certainly need. Yeah, I think it is fair to say, because I've asked there's some stakeholders we work with, farm workers in Florida, and I always ask, is it like, do you really need more evidence? And in this case, they say, yes, we do, just because it's not available. So I don't know if that fully answers.
Okay. Sorry, Amber.
Hi, Zach Edelman with LADCO. So we've been talking about using some of these data sets to fill in gaps around the world that are quite sparse. If we think of the other side of the spectrum, in a place like the United States, where we have a relatively data-rich network, every 5 years, the Clean Air Act mandates that state and local agencies evaluate the monitoring networks and to basically do a monitoring network evaluation. It happens on like the round numbers, next one's due 2025, 2030. Have you considered how you might be able to use these data sets, use the endpoints that you're looking at to reach out to US EPA to ask them to consider new ways to evaluate the monitoring networks, to monitor for things? You know, they're looking at NAAQS compliance at this point, but there are other endpoints that we're concerned about.
That's a great question. I am aware of studies that have applied satellite data to suggest locations where new monitors would be quite useful. But I think your question is broader than that in suggesting, well, what if rather than addressing a NAC standard, what if we thought about where perhaps mortality-driven outcomes or morbidity-driven outcomes, could we aggregate that information in a way that identifies locations with new monitors? And that's a great idea. I'm not sure if I've seen studies in that direction, and that could be a useful application. Yeah.
Okay. Can we squeeze in one last question from, I think I saw Amber's hand.
Maybe this is a conversation for offline, but I'm following through with a comment that was made earlier. But let's say we do have the data and we do know that this stuff is bad for our health, whatever this stuff is, but our livelihoods depend on it. And where we're in communities where we can't suggest more monitors because of the political will in that particular community. So do we have, you know, and Chris, you might want to address this or others, but and maybe the woman at the end here might want to make a comment. So they really have nothing that they can do. I mean, perhaps, I mean, I don't have any answers here, but perhaps HEPA filters in schools and awareness of the community. But there's these huge barriers that because their livelihoods depend on where they are or their families, that they're kind of stuck. And there is no political will. There's only a political or agency pushback.
Yeah, I'm not quite sure why this is kind of not an OpenAQ question, but I'll go ahead and answer it or suggest that, again, some of these community projects that are doing air sensing are using them again they're using them to educate their own constituencies about when to stay inside or not. Some of them are in schools and so on and so forth. So there are measures you can take to protect your own health. And then the air sensing, there may not be the political will at your state legislature, but if you go to your air quality authority, they may be willing to put in a monitor to start monitoring, at least get the ball rolling.
I was the one that posed that question. I'm actually going to be presenting this afternoon, so I can talk a little bit more about that. I don't want to take up much of your time, but there is some political pushback sometimes, and because of communities and depending on location and access and resources, it can pose a problem with, you want to address it, but the challenge is when you address it, what's the impact that happens to you, personally, financially, whatever have. But I'm presenting this afternoon, so I'll talk a little bit more about that.